What the data shows here is information about what happens when we have some group Z on the benzene ring. And the two questions we want to ask is, when we add our electrophile, does this make this compound react faster or more slowly than benzene? And also, where does the electrophile go? So in other words, we're looking at the effect on the rate and the effect on the regiochemistry. And this is a well-studied reaction, so there's lots of data, and we can look at both and then see if there is a correlation between the two. So first, let's look at where does the incoming electrophile go relative to the existing substituent. And recall that we can talk about positions on the benzene ring as being ortho to the original Z, meta, or para. So going up here to our reaction, is the electrophile going to go ortho, or is it going to go meta, or is it going to go para, or some combination, or is it one of those impossible to tell situations? Probably not, since I'm doing this presentation. So if we look at the data, and what we've done here is we've used a consistent electrophile, and that's important that we're always nitrating, because if we did one reaction by nitration, another one by alkylation, another one by chlorination, then we'd be changing too many variables at once and our data wouldn't make much sense. So we're going to go ahead and look at the data. And what we've done here is we've varied the group Z that's attached to the benzene ring. And so if you look at this data, you can see that it appears that it either goes ortho and para, 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 or it goes mostly meta. And again, this is not, in neither case is this an absolute thing. It appears to be more of an absolute thing for the ones that go ortho and para than it does for the ones that go meta. There's more of the other possibility there. And so we can go ahead and highlight this using the correct color. And so we have these particular groups seem to send the incoming electrophile to the para position, whereas these particular existing groups seem to send the incoming electrophile more to the meta position. And we can use terminology here. We can refer to the ones that tend to send it ortho and para extremely originally. We can refer to those as ortho, para directors. And then we can, only make sense, refer to the ones that direct it meta as meta directors. And I'm going to put directors in quotes for a reason that we'll talk about eventually. All right. So it appears that we have groups that, again, direct ortho and para, and groups that direct meta. Now let's take a look at the rates. And so in this chart, we have the relative rates of the nitration of benzene. And again, we're looking at how does an existing substituent affect the rate of the reaction? Does it make it faster, or does it make it slower? Or does it occur faster or more slowly, depending on how you want to present that grammatically? And if we look at this chart, everything is relative to benzene. So if Z is equal to H, we have benzene. And so we can see of the groups that we have here, we have two that make it faster, that do what we call activate. And then we have several that make the reaction slower or do what we call deactivate. And we can try to divide this table up a little bit using maybe a different color. So again, relative to hydrogen, we have the activators and we have the deactivators. And you can see that of the deactivators, that the nitro group is the most pronounced of those. Another thing that we can do with this data is to look to see if there's any correlation between the rates and the regiochemistry. And it wasn't easy to find data, but if you look at, let's say, the methyl group, and we can say that maybe the OH group is going to be similar to a methoxy group. Both the OH and the methyl group are orthoparadirectors, and notice that those are also activators. Whereas if we go looking for these other ones in the table, which were pink, so nitro is a deactivator and also a metadirector. This group has an ethyl, that has an ethyl. So again, we have deactivator. Go back to this cute little pointer. We have a deactivator that's also a metadirector. And things are looking pretty good until we get to the halogens. And with the halogens, for example, chlorine, you can see that chlorine is a deactivator, but it is an orthoparadirector. Based on this data, and although it's a small data set, it's consistent with the other data, what it's safe to say is that all activators are orthoparadirectors and all metadirectors are deactivators. And my language there is very precise. I'm using, as you notice, a different subject each time. And the reason for that precise language is that we have these halogens that are exceptions. Not an exception to this, but an exception to the fact that this correlation between the directing effects and, the directing effects and the rates. So we can go down and take a quick look at this data. And what you really want to focus on here are the numbers. So what the numbers in blue and red indicate is the relative rate of reaction of each one of these positions relative to what it would be in benzene. So again, benzene, everything has a relative rate of 1. And don't worry too much about those numbers. The important thing to note is that when we have these activating groups, which happen in this case to be a methyl group and a tert-butyl group, notice that the ortho and para positions are more activated than the meta position, but even the meta position is more reactive than it is in benzene. So in other words, what happens is all of the positions of the ring are activated relative to benzene. But the ortho-para positions are activated more. Now if we come over and we look at these two deactivators, you see that what happens here is that all of the positions of the ring are deactivated. The ortho position is deactivated, the meta position is, I don't know why that's a 0, is deactivated, and the para position is deactivated. Let's look at these numbers. So deactivated, deactivated, deactivated. But what you can say here is that the meta position is less deactivated than the other positions. So again, it's not like this particular group with this carbonyl is directing things towards the meta position as much as it's saying, please stay away from the ortho and para positions, and the meta position is the least of the evils. But again, these deactivating groups deactivate all of the positions.